Okay, so good afternoon. My name is David Turner, and I look after XML at Microsoft. I cover the broad, very horizontal aspects of XML as it affects the various products that are rapidly adopting the use of XML within Microsoft. And as a part of that, I'm also the Microsoft's representative to the advisory committee on the W3C, the World Wide Web Consortium. So I'm actually part of the process to get a lot of these standards worked through. So, jump right into it. XML is not cool. Contrary to what you keep hearing, it is not cool. It is the right thing to do, and there's a big difference. We have not adopted XML so broadly within Microsoft because it was a cool thing to do. We are not the Johnny-come-latelys of XML. We were on the original XML working group at the W3C. As well, we shipped the first commercial parser in Internet Explorer 4 back in 1997. So we've been in this game for longer than just about everybody. And our reasons for doing it back then certainly weren't because it was cool, because you couldn't get people to spell XML in 97. We did it because we saw the value in terms of the things that we're now beginning to see with the whole Microsoft.NET platform. This quote's pretty interesting. Microsoft is the most influential company driving the deployment of XML. That came from a Zona research report back at the end of last year. And what's really interesting about that quote is that it is not an opinion, it's an observation. And the distinction is that this was a report, or in fact a survey where they had gone out and interviewed a whole series of enterprise-level customers and asked them about their usage of XML, what tools they were using, what platform, et cetera, et cetera. And the end result was more people were using Microsoft products and technologies to build their XML solutions than any other company. And the result was this was one of the observations that they made at the end of the survey. So this was not Zona making any broad prediction or giving a value judgment of us. This was drawing a conclusion based on the results they had seen in a survey. And now that's a year ago. And we've been blasting ahead ever since. So, I'm going to run through 4 major topics here. Briefly review what the motivation is, why it is we're using XML, what's the goal, where we're going to see it showing up. Talk about the standards that you hear all the time, this alphabet soup of standards and all these 3-letter acronyms that get thrown around like crazy. Sort of like all the other 3-letter acronyms you hear thrown around in the tech industry in general, but this particular group kind of muddles things. Then I'm going to talk about how we're providing support for XML throughout our platform products and so on. And then finally talk about how we're using XML within the rest of the company. So not just within our developer tools, but elsewhere as well. See at the bottom, this is not an XML tutorial. I'm not going to be drilling down and getting into deep discussions on how these particular standards work and the nitty-gritties of the details of any of the standards. There's A, not time for that, and B, that's not what I'm after. I have 2 goals here. The first is to help you understand the different standards that you hear about when people use XML, because of course a lot of people do think that XML is cool. XML, most people don't realize this, actually stands for the excellent marketing language. And so everybody throws that ML part. They either put an X in the name or they put an ML at the end of it to get that cachet of what's going on. And so you hear all of these things, and one of the problems is that you get this picture of XML that sounds a whole lot like an old Saturday Night Live skit. It's a dessert topping and a floor wax. So, you think, well, wait a minute, how can I be doing serialization of objects and technical documents with the same thing, right? These are supposed to be different beasts. How does this all work together? So one of my goals is to show you the different layers of the standards that you're likely to hear about or may already have heard about, show you how they fit together, and in fact how they all work together. And then second, I want to show, quite frankly, the incredible depth of XML support within Microsoft, both within our products and our services, I mean, the adoption within Microsoft is beyond, I think, what any other company could show, given the scope of products that we produce. So, the motivation. Has anyone seen this slide yet? Just checking. I'm not going to spend a lot of time on this. It's probably been beaten into you so far. Unfortunately, this presentation probably should have been a couple days ago, because it would have helped lay the groundwork for some of these things that you've been hearing over the last few days. But that's okay. It just means I don't have to talk about this one now. So it's been beaten into you, this whole idea we're building web services and we're using XML as a way of communicating between things. And what this leads to is this universal sort of connectivity between our own products, between devices, between other people's services, between other people's devices. So we have this sort of web ether that that's all being connected together, and we're using XML as the underlying technology, if you will. A few of the key benefits. It's a universal data exchange format. It's fairly simple at the most basic level. It's open, and it's broadly adopted. The broad adoption, of course, being a very important one. I want to talk really quickly about the simple part. As you'll see in a moment, as I start going through all the different standards, XML standards, even at the core level, it can get a little scary because you see all these pieces building up and you think, oh, wait a minute, this doesn't sound so simple anymore. Well, the neat thing about XML, and this, you'll see this especially as I start sort of layering these things together, is that you can always just use it in its simplest form. When the people in the working group were building XML, one of the goals was to keep it as simple to use as HTML. That people could just do really simple, straightforward markup like they were doing with HTML already, but now have a little more intelligence associated with the information. So the beauty of XML is that you can keep it simple, and you can work with simple marked up data structures. But as your applications become more sophisticated, as your needs grow, and you need to start adding in other things, then there are other pieces that can be added in. In the same way as building a website can be as simple as writing an HTML page, right? Doesn't take much. You got an HTTP server, it's just sort of there in your Windows box. You code up an HTML page, you're done. Gee, this web stuff's pretty easy, isn't it? So it's very easy for someone to get started, but obviously, again, as you've been hearing in all these sessions the last few days, as the needs of the applications and solutions grow, you need more tools, you need more services, and yes, the complexity can rise, but ultimately it's because you're going to get more out of it. But the universality of the format is really what's key. But it's not just about the data. We can also use XML as a way of defining the relationships between things. So in effect, we can use XML as defining a contract for how people are going to exchange data. And what's really amazing is that the impact on software as a result of XML is pretty dramatic, because it creates a degree of separation that we've not had before, such that the code that you use to produce or consume at the XML on either end, in many instances becomes less important than the data itself. Not your code, of course, the other person's code. But that's actually kind of true, because you don't really care anymore what the other person's doing. We're moving into this world where it's not just the data that's being marked up in an open format. We're using communication protocols marked up in XML, so that the person on the left can be using a Linux box in Perl script, and on the right, that's your Windows 2000 box in C#. And if the one on this side decides to switch to Windows 2000 tomorrow and use VB to build their web service that you're now already talking to, you have no idea that that's happened, right? As long as the information going back and forth across the wire continues to conform to the contract that you agreed upon, the definition of the protocol, the definition of the data structures, then you don't really care how they've built their system on the other side. You don't care what platform they've used, what languages they've used, what APIs they've used. So there is not a requirement to have the same programming language on two boxes just to get them to talk to each other. You get a very high degree of separation between the two ends. So, let's talk about how we get there through the standards. Is there anybody here who doesn't know about the W3C, World Wide Web Consortium? No? Okay, good. So, of course, everyone would be afraid to put their hand up if that was true, wouldn't they? Everyone would look around at them like this. Very quickly, the W3C started out back in the 94, 95, primarily to provide a place or a home for the growing web standards, and HTML and HTTP being the main ones. HTTP has since moved off to IETF, same place that TCP/IP lives. Since then, as the web has grown and as needs have grown, other things came along, and XML was one of them. Well, XML 1.0 was sort of the foot in the door, and once we had that piece done, people began to see needs for other related pieces, which is what I'm going to run through here. So, as I mentioned earlier, we were one of the co-founders of the original XML working group. Jean Paoli, who's now working on NetDocs, is, or was rather, one of the co-editors of the XML 1.0 specification. So as I said earlier, we were in there from the beginning. We were contributors to the original spec for XML 1.0. So what you see on the screen is a list of what I consider the core XML-related standards that the W3C is working on. There are some others. Putting them on the screen, in fact, would have just distracted because they're sort of at a level that most people won't even see. The people building the parser may have to worry about it. People using a parser probably won't. So there's some other bits. This is not exhaustive, but these are sort of the key ones that people are going to need to think about and know about when they're thinking about XML standards. So XML 1.0 is the core set of rules that says use pointy brackets. By the way, do you know why they chose pointy brackets instead of square brackets? Pointy brackets are more aerodynamic. Yeah, that's right. It goes faster, right? Looking for scalability here. Or not. So XML 1.0 is the basic set of rules that defines how you define a tag, how you define attributes, how you define the relationships, and so on. It is the starting point for all of the other things. Then namespaces was released, and namespaces is a specification that allows you to distinguish between the definitions that you're using. One of the things that people are starting to do with XML is create aggregated blobs of information, where data gets pulled in from a number of different sources and sort of lumped into a single instance. The problem is that if I get customer data and I get book data and lump them into one document, I'm going to get some collisions. I have things like titles in my contact information. I also have titles for books. And so there needed to be a way to disambiguate those namespace collisions, those tag collisions. And so the namespace specification was designed, built exactly for that reason, so that you could have a way of uniquely identifying the namespace that defines the contact information as distinct from the namespace that defines your book information. An interesting aside about namespaces, it says nothing about pointing to the actual definition of, say, the schema or the DTD that defines your data sets. People are looking at ways of using it that way, and certainly we are within our own products, but that's not actually part of the specification. It never says that the namespace has to point to something discoverable or retrievable. It just says it has to be a unique identifier, kind of like a GUID. So then we have XSLT and XPath. Now, XSLT and XPath are sort of a step away from the first two in that the first two are all about defining your data. XSLT and XPath are about manipulating the data or working with the data. XSLT stands for Extensible Style Sheet Language Transformation. Extensible Style Sheet Language Transformations. During the XSL working group process, which was originally designed to do style sheets like formatting, like CSS, they discovered they had built this really powerful declarative way of manipulating tree structures, which is what XML generally is used to represent. So they formally split it. So there's one half that deals with these things called formatting objects, which are, again, a whole lot like CSS and deal with block elements and indentations and fonts and, very document presentation-oriented stuff. And the other was the transformation section, which dealt very much with how do I take an invoice that has been designed according to schema A and apply a transform to it of some sort so that it now takes the same data but conforms to a schema that according to schema B. And that's a very, very important component when we're working with XML. Who here has been to any of the BizTalk sessions? Did you hear them talk about XSL at all? XSL is a core part of our BizTalk server product. That scenario that I described where you try to take an invoice and transform between schemas is a very common scenario. One of the interesting things about, actually, I'll get schemas in a moment. So XSLT was designed to do the transforms. It is, as I said, it's a declarative way of transforming hierarchical or tree-based structures from one tree to another tree. XPath was an interesting side effect from that work as well. What they discovered as they were working on this is that they needed a way of pointing at something and identifying something within a tree, either a node or a subtree or an attribute. And so if you're going to say, well, I want to take this element and I want to turn it into that element, how do you define the selection criteria for the starting point so that you can apply the transform rules? So what they built up was effectively a pattern matching syntax that was, again, originally deeply embedded in part of the specification, but when they discovered its value and discovered that that was a useful way of referencing XML structures, they pulled it out so that another spec, again, which is not up here, called XPointer, could use it as well. So they saw this as being a portable way of referencing data. So when you want to point to a particular structure in an XML document, you can use XPath for that. And in our parser, which I'll talk about later, we have the ability to effectively query XML structures through the DOM, Document Object Model. And we use the XPath syntax for doing that. So we took it out of the domain of just doing simple transforms and used it as a way of querying against hierarchical structures. So those three specifications are all done. And actually, in the case of XML, well, in the case of rewind. In the case of XSLT, they've already started work on a 1.1 as well as a 2.0. But as far as our customers go, those things are rock solid, and we're building support for those into our products now. The next layer is XML schema. The original XML 1.0 specification had a thing called a DTD in it, a document type definition. The problem was that DTDs weren't very good at defining rich structures. They could define hierarchy, but that was about it. They had no data types. Well, one of the problems is DTDs weren't using XML syntax. So when you were trying to build an XML processor, you not only had to parse the XML string syntax, you also had to parse the DTD syntax, which was just completely different. So all parsers, by definition, were much more complicated than they needed to be because you had these two very different parsers built into the same unit. And the third problem was that DTDs simply were not extensible. So the example that I gave you earlier of taking book data and combining it with contact data and coming up with a single structure effectively couldn't be done using just DTDs because there would be no way to build a new definition that would combine definitions from the book definition and the contact definition. So this produced something called XML schema. We contributed 2 of the 4 documents that went in to start that working group. And one of them was called XML data, and I'll talk about that in a few minutes. So we were also one of the key, actually we're also initiated on the XSL work. In fact, pretty much every case we've provided the main input documents to all of these to help jumpstart. XML 1.0 being the exception because it started off with SGML as the main input. But in all the other instances, we were one of the prime motivators that started up these working group activities. So time-wise, XML schema, 3 to 4 months away. It's expected to, if all goes well, there should be what's called a candidate recommendation coming out. We're still in September? Yeah, still in September. Later this month. Candidate recommendation in the W3C speak means the working group is pretty sure they're done, but can't know for sure until people have built implementations. So this is the chance for companies like us and IBM and others who actually go off and have to support or actually build the processors that support schema, gives them a chance to go off and actually try and build one and see if we've missed anything during the work. Given that we've all been doing this all along, we actually expect that there's not going to be any big issues. And so if all goes well, the XML schema work should become a final recommendation by December or at the latest January of next year. So it is also, for all practical purposes, imminent. So the candidate recommendation, which should come out before the end of this month, is pretty close to what the final thing should look like. So if any of your customers ask you, or if you're interested in looking at W3C schema, I would say that the candidate recommendation is a very good place to start. If you haven't already looked at it, if you have, then this will just be an update. But if you haven't gone down that path yet, I would say wait for the candidate recommendation to come out in a couple of weeks. Extending from the XPath work, sorry, not to say starting with, but based on what we saw with the value of being, and the need of being able to query XML structures from some of the XPath stuff, there's another working group called XML Queries that is, in the simplest terms, trying to build the equivalent of SQL for XML structures. Now, of course, that raises the question, well, what about SQL? And that's, in fact, something that has not been resolved yet. The people we have working on the working group are very aware of it. Paul Cotton, who recently came to Microsoft from IBM, has actually been working on SQL and ODBC for many years, doing the standards work, not just as a dev. So he is very familiar with the issues, both in terms of the mechanical process of getting a standard done, as well as the SQL language itself. And so we have some very, very good people working on that. And what they're ultimately trying to come to is something that is not, either does not collide with SQL or at least is not alien to SQL. But in the short term, as a minimum, what we'll have is a two-pronged approach. If your data is well-structured, rectangular, kind of like what you know already, then clearly SQL is still a really good way of doing things. On the other hand, if you're coming at it, looking at it from a hierarchical structure, which of course is the default state of XML, then XML queries will be the optimal sort of input point. Now, things are being done to SQL to help it deal with some of the hierarchy, and similarly, there's ways of mapping hierarchy into rectangular sets as well. So there will certainly be some overlap. I think in the first iteration of queries, we will have two distinct things. And it's probably going to take a couple years before those things get brought closer together. Of course, all this stuff, everyone knows that XML is just text, right? It's just clear text going back and forth over the wire. Therefore, security is obviously a very important thing. Now, we have security on the web already, right? We have things like SSL and so on. But the problem is that that's an all or nothing proposition. The entire blob gets locked up. As we start sending XML-based messages over the web to a greater and greater degree, what you're going to find is that, or not find, what you have is you have an envelope, say based on SOAP, and you have a payload, which could be effectively a method call or a purchase order. It doesn't really matter. You're sending an XML payload inside an XML envelope. Well, the payload, you want to keep locked up tight from the starting point to the end point. Well, that's fine. But what if that message has to move through a series of intermediate points? Those intermediate points need to read the envelope in order to know where to send the document next. So it would be kind of like taking a letter, stuffing it in an envelope, and then encrypting the address and dropping it in the mailbox, right? And you know that the guy you're sending it to can understand that encrypted address. U.S. Postal Service ain't going to make it. So that's the kind of problem they have. And in order for them to figure it out, they may have to tear open the envelope to figure things out. And clearly that's not what we want. So there is a need to provide a granular level of security to our data, to our information. And in fact, in many instances, even within the payload itself, there may be needs for encrypting just parts of it. So you may have a purchase order, and there's a signature block, some sort of electronic signature that's in there, and that's the part that needs to be secure or encrypted. And the rest isn't so important. So it's because of that kind of granular requirement that we need an XML digital signature spec. And that's being worked on. And again, that should probably be done sometime next year. And then finally, something called XML protocol, which is what the W3C has named the, SOAP. So we submitted SOAP to the W3C. We helped initiate an activity which was formally announced last week. And they've called it XML protocol. Heaven forbid we stick with the Microsoft name of SOAP. So we have XML protocol. And I'll talk a bit more about that in a moment. That first face-to-face meeting is in fact going to be in October, and based on the schedule in the charter, it's expected to be completed about mid-next year. So, has anybody here run across this particular issue? XDR versus W3C schema. I bring it up so that we can put it away. It's as simple as that. The reason the W3C schema work started was that DTDs were not sufficient. As I said before, the DTDs don't support data types. DTDs were not extensible. DTDs were not XML. And there were some other things as well that they couldn't do, that we needed to do. They were not capable of representing the data structures that we knew we wanted to serialize or map to XML. So we needed something different. And quite frankly, everyone agreed. Right? The schema working group started out like that. Nobody had any complaints. Everyone said, yes, this is the right thing to do. Problem is timing. Timing. The problem is that our customers had those problems today. They wanted to build solutions today. You guys wanted to build solutions today. And DTDs weren't going to cut it. You needed the validation, the data typing, and so on. But again, DTDs wouldn't cut it. And so, I mentioned earlier when the W3C, we submitted 2 documents to the W3C. One was called XML data, and another one was called DCD, which was a joint thing we did with IBM. But what we did is we took our XML data spec, and we produced a reduced subset of it, effectively simplified it, because it was actually pretty big and a little on the complex side. So we produced a reduced subset, and we implemented that subset in Internet Explorer 5, which shipped in March of '99. So it has been 18 months since we shipped this. And just in case you forgot, in the previous slide, XML schemas still aren't done. So our intention was to provide an interim solution. We knew what our customers needed. We had a solution that we could implement, but we were at the same time working on the W3C schema work. So unfortunately, there has been some misunderstanding. Our competitors, of course, have taken every opportunity they can to point out this apparent discrepancy, and that's been part of the problem. The press, about a year ago, was not terribly friendly to us on this particular front because they used this as an excuse to say, look at how Microsoft is trying to do bad things in the XML space. Well, that's not it at all. As I said, the intention was to provide an interim solution so that people could get the benefits of schema while waiting for the schema work to be done. The last 2 points there are very important. If someone has chosen to use XDR previously or even today, we're fully committed to supporting those customers. We're not going to abandon them. We're not going to suddenly break things on them. But what we will do, and to help them, we will provide tools as necessary to transform their schemas. So they'll transform them from XDR format to XSD format. And the interesting thing is that an important point to keep in mind, there is no data integrity issues related to using XDR or DTDs or XSD. If you put DTDs at the top of the stack there, above XDR, what you get going down the stack is increasing ability, where the previous one is a subset of the next. So DTDs are a subset of XDR. That is, anything you can define in a DTD, you can define using an XDR schema. So anybody who has written a DTD can just get a simple tool, transform it into an XDR schema, and presto, they have their information in this better format. Similarly, if they've already defined their information in XDR, once XSD is complete, we will provide the same kinds of tools that will allow you to just turn your XDR schema into an XSD schema. What this does not change are the underlying documents. just because you used a different syntax to define what a purchase order looks like. So I used a DTD first for my purchase order, then I turned it into an XDR schema. Validating against the XDR schema will not give you different results than using the DTD did. The documents remain the same. You're just using a different syntax for defining the exact same relationships. And the same is true going from XDR to XSD, again, because it's a subset. You don't break the documents just by switching schema formats. Now, one of the other pieces of FUD that gets thrown around is that, well, if you use XDR today, you're going to have to rewrite all your code when XSD comes out. Okay. So let's look at the amount of code you have to rewrite if you use DTDs today and then jump to XSD versus the amount of code you have to rewrite or adjust to get from XDR to XSD. And the fact is, from XDR to XSD is about this much. From DTDs, it's about this much. Because DTDs know nothing about data types. They know nothing about blank, blank, blank. Stall. Anyway. Yes, thank you. Namespaces. That was actually the main one I was trying to remember. Thank you very much. Namespace support. There is no namespace support in DTDs. Of course, XDR and XSD both support it. So if you've already built your app to deal with namespaces and deal with data types, then going to XSD, it's a breeze. In many instances, it's just switching formats and using that validator instead of that validator, that interface instead of that interface. Yes, a question? Quick answer, don't know. The problem is most of what gets added is in fact getting into a higher degree of complexity. So you already get namespace support. You already get the data type support. Well, in fact, I think they've expanded the data types a little bit. Yep. Oh. It allows... oh, there was another one. Told you, I'm just blanking on this right now. Sorry, someone's going to say something here. Yes? Oh, different question. I'll come back in a sec. So I apologize. My brain is just stalling on the XSD stuff right now. But the good news there is the fact that there is not that much of a difference for many people. The subset that we implemented in XDR is in fact most of what most people will need. So if the W3C schema only did XSD, there's a large number of people who would have, or sorry, their XSD stuff only did what XDR does. There's a large number of people who would say, fine, I'm done. Right? They didn't necessarily need more than what you could do. They just needed the better syntax and namespace and data types and so on. Now, as you start getting into trying to use schema to describe objects and so on, there's some relationship definition stuff that's very important. But starts getting a little more gnarly as well. So this gets into what I was talking about at the very beginning, where XML can be very simple, and you can define very simple structures, but it can also start getting much more complex as well. And I'm not an XSD expert either. I mean, there's 3 main sections of this spec, and it's just I've delved into it to the degree I needed to, but I'm not the expert. Yes. Oh, XDR. Yes. Well, yeah, at the top, see it says XML data reduced. XML data was the name of the specification that we and some partners submitted to the W3C, which in their process becomes what's called a note, and that was used as an input document to the W3C schema working group. We also submitted another one called DCD along with IBM, which had some variations in it. But yeah, the XDR definitely came before XSD did. Someone over here? Nope. Okay. So the whole point here is, just to make it very clear, the XDR stuff gave our customers value today. We have full intention to support XSD when it's done, and we will start moving that support into our products. Those that are like BizTalk Server, for example, that are using XDR now, they will be revved over time to support XSD. By the way, all the .NET stuff, Microsoft.NET, Visual Studio.NET, the .NET framework, all that stuff, that's based on XSD. So if you have any customers who doubt, and you've got something on your screen, VS.NET or any of the other tools, just whip it up and show them. XSD is what we're using. It is what we are building the .NET framework on. So there should be no question in anyone's mind that this is the direction that we're headed and that XDR was just a temporary thing. So let's get on with it. So what I want to go through now is how these things start fitting together, where all these pieces fit. So sort of got three buckets here, three columns that I'm going to use. So we start with sending stuff back and forth over the wire. We're talking about the web, so it's obvious we start with TCP/IP, mail, HTTP as our way of communicating. So the first decision you make is, I'm going to use XML to structure my data. That's a first step. That's the starting point for all the stuff that we're doing. And basically everyone has taken that step already. That's pretty much a given. From there, though, you need something else. You need a way of describing what that data is. What is it that I'm sending to you? Is it a purchase order? Is it a book record? Is it a contact record? Assurance record? Am I making a procedure call? Am I, sending? Am I doing UPnP? I mean, what is it that I'm doing? What's the definition of that data structure that I'm sending back and forth over the wire? So the namespace is the reference to that definition that gets sent back and forth, and of course, XML schemas, as I was just talking about, is the way that you formally describe what your document structure looks like. So if I want to tell a partner what a purchase order must look like, you give them a schema. If I need to tell them what a particular message looks like for invoking a web service or talking to a web service, I give them a schema, or more likely a collection of schemas to say, here are the messages that we can exchange between us. And then you need a way of exchanging them. So we said we're going to use XML. We've used schemas to define them and namespaces to reference them. But now we have to figure out how we're going to send them back and forth. What is the means to take that XML payload from my machine to your machine or my app to your app? And SOAP, and through W3C XML protocols, that's our starting point for defining that basic messaging layer for moving stuff back and forth. I'm not going to spend too much time on this, because I'm sure you've been hearing more about SOAP in other places as well. But again, it stands for the Simple Object Access Protocol. And the goal is to provide a lightweight protocol for exchanging information. SOAP's goals were not to become the Uber messaging system, to provide all the bells and whistles and features necessary to send any message to anybody anywhere. It was, in fact, quite specifically in the opposite direction. What was that minimum set that is necessary regardless of what type of messaging system you want? Whether you're doing universal plug and play or invoking web services or any other types of messaging, reliable messaging scenarios. We wanted to come up with that basic layer that all of these other things could use. Key aspects were flexibility and extensibility. You had to be able to add to it. Because one of the things that makes, it's actually interesting, this whole XML space is unique. Because there is a dramatic change in the way that people are thinking about systems and information. Changing your data or dealing with variant data structures is not an exception anymore. It's the rule. You don't build systems hardwired to a particular data structure. You deal it to deal with, maybe be optimal for a particular structure, but you build it so that it can adapt to new data structures or variations or versions of those data structures in a seamless and natural way. And one of the reasons is, in fact, I meant to talk about this when I talk about schema, one of the reasons is that you will never get people agreeing on the same schemas. You will never have one invoice schema in the world. You will have many invoice schemas. And the reason is that you will never get the legal industry to agree with the insurance industry, to agree with the shoe industry on what an invoice should look like. There may be a core piece that's common, but on the whole, you're going to be dealing with schemas coming from different groups. Now, within a particular trading circle or application domain, it's right to have a single definition for things. But on a global scale, that's not going to happen. So let's build systems that don't understand that concept. And quite frankly, that's a big part of what BizTalk Server is all about. It's about building a message-based system that understands that I'm doing business with lots of people pretty much similar data is moving around, but those definitions don't always line up. And so I need to have a tool that knows how to deal with that in a native way. And so BizTalk Server provides those capabilities. Well, SOAP has to understand those same concepts. I have a core protocol for doing messaging, but at the same time, I know today that as soon as we say we're done, something else needs to get added on. Maybe it's something you and your partner add on for your own application, or maybe it's something that the legal industry needs to add on, or maybe it's digital signatures that need to get added on. So we're building SOAP now, or we already built SOAP, and we knew digital signatures were coming. We didn't know what they were going to look like, so we couldn't build that in. So instead, we had to make sure that it could accommodate it. And so that's where the flexibility and extensibility becomes so important for the design. Status. We originally released SOAP 1.0 last year, but the one that really matters is SOAP 1.1, which we released in April this year. And that was the document where IBM's name showed up as a co-author of the specification. And that was a pretty key point for SOAP because a lot of people looked at SOAP before 1.1, and there was a couple of issues that they had with it. One was that not the technology of the specification itself, but the terminology of the specification made it sound hardcore, or at least extremely RPC-like. It didn't look like a generic messaging protocol. It looked like you needed to use it for RPC, or you should only use it for RPC. And we knew that wasn't right. We knew that was one of the scenarios, but we wanted people to understand that, no, this is all about a lightweight protocol. This should be used for other scenarios as well. And so that was one of the major changes in the 1.1 specification, was not so much a redesign in a significant way, as much as a clarification and a changing of terminology, so that the samples weren't necessarily hardcore RPC, and we talked about the usages in more open ways, or more generic ways, rather. The second change was, in fact, bringing IBM on board. The original SOAP 1.0 spec had Microsoft, Don Box from Developmentor, and Dave Weiner from Userland as listed as a few people from Microsoft, but those other two as outside authors of the document. And that actually gave it a dramatic amount of credibility up front. And the fact that the primary SOAP discussion list is hosted on the Developmentor site also gave it a certain degree of credibility. But, you know, Don Box is pretty much known as a hardcore Microsoft supporter, and, well, Dave's well known in certain parts of the industry, but not in others. And so, you know, people don't necessarily know where he fits in, and so therefore they see this still as a Microsoft thing. By having IBM's name on there, that gave us a lot more credibility. All of a sudden, people were more willing even just to look at it. They said, hey, Microsoft and IBM working on this thing together. Okay, this isn't just a Microsoft thing anymore. And so that was a very important step for us, because it got people looking at it and in fact, sort of believing it more readily, simply because it now had this more open feel to it by including more partners. Continuing down that path, we submitted it to W3C, and when they accepted it, it becomes what's called a note. Two reasons for doing that. One, again, was to get this idea of openness. We wanted people to understand that this is not just a Microsoft thing, that this is something that we want people to adopt, we want lots of people to implement. And the reason we want that is that there is no value in owning that part of the equation or that part of the architecture. It's kind of like trying to own or have a proprietary hook on HTTP. HTTP's value comes from being ubiquitous and the same everywhere, right? HTTP just works no matter where you send a message. You send the proper request, you get the right response. You send the wrong request, you get the right response, right? That's how HTTP works. Doing extensions and weird stuff on HTTP is not going to get you very much. That's not where the value add comes. On the thing that implements the server, you know, how fast can it do and all that, absolutely, right? The implementation's always a key piece. But the protocol itself, there's no competitive advantage to doing some variant implementation on HTTP. And we see SOAP as being in that same space. The value in having a lightweight protocol for all types of messaging systems has a very high degree of value, like having HTTP being ubiquitous. So that regardless of whether I'm sending an RPC request or doing universal plug and play or doing a BizTalk message or doing something else, the fact that they all have the same basic message protocol as the envelope moving information around means that we can optimize our systems for that. It means we can build hardware-based routers. I got to tell you, probably I've been dealing with XML and markup for 7 years now, at least. And the weirdest thing was being in Intel's building a couple months ago, and they've got these pieces of hardware with XML on it. I mean, that was like, wow, this is really hit somewhere when you've got companies like Intel making XML hardware. Now, turns out it's in fact all in the software, but that's okay. But they're still selling a piece of hardware ultimately. And I also know that Cisco is working on this. And so if every message has that same basic wrapper around it, the same basic envelope, you can start building routers and caches and, well, maybe not caches, but certainly routers and things to optimize the movement of these things, redirection, load balancing, and so on. So we can actually build a very efficient infrastructure like we've already been doing for HTTP. Similarly, from an app developer standpoint, the predictability is wonderful. What it gives you is a scenario like this. So over here I've got a BizTalk server running, and over here I've got a client that's going to make a SOAP request for, I don't know, get weather. And this is the BizTalk server front end for an insurance company. So it's looking for claims and financial data. So I send my SOAP request over to this BizTalk server. If they were using different messaging structures, and then let's say I'm doing it over HTTP, the problem is that I'd send this, and the thing on this side would say, no comprendo, and don't get it. And I don't know what I'm going to get back. My client will not get a reliable response to know, did it work? Did it fail? How did it fail? Did you even get it? I don't know. What did you know? In the same way that this side may not understand the request, the response it gets may be just as undecipherable. But if we have SOAP and BizTalk, and they're both based on the same message protocol, that same envelope, then what happens is the BizTalk server says, aha, I'm being asked to do something. Don't know what I'm being asked to do, because that's not something I understand, but I know I was asked something. And by asked, of course, it's an implied way, right? You sent me a message, and it's implied what's meant by that message based on how the service is defined. So it's been asked to do something. And because it doesn't know, it sends back a predictable response. In the same way that with HTTP, if I send a request to a server and it doesn't know what that request is, it will send me back a well-understood response, and I will then know what happened. You get that same benefit with this lightweight protocol. And that's why we think it's so important to be done in an open way. Yes? No. The question was, could SOAP become an alternative to HTTP? And the answer is no. They actually serve different purposes. HTTP is still the way the message gets moved back and forth. So if we think of the US Postal Service, US Postal Service, the infrastructure represents HTTP and TCP/IP. It is the, let's say, the physical vehicle for movement. That whole stack is the physical vehicle for moving along. SOAP represents the envelope, the physical envelope that you're going to use to send the message from point to point. And then you take whatever the data is and stuff it inside the envelope because that's your data. But because you've used a standard way to wrap and address it, right? And wrapping could be putting brown paper around a box, or it could be a white, standard envelope. That doesn't matter, but you've got this standard addressing format that you're using. That means the US Postal Service will know exactly what to do with it, right? Those are the conventions that make it work very well. Well, work. And so HTTP, again, and TCP/IP, again, that whole network stack is akin to the US Postal Service. The envelope and how you address it would be akin to SOAP. And then, again, what you put inside is just your payload. Right. So the question again is well, we're talking to different layers. And what that means is that you could use SMTP instead of HTTP. You could use MSMQ. You could use a lot of other transport protocols as the way of moving the XML document or message around. The SOAP spec defines a binding to HTTP, but it is not an exclusive binding. And in fact, in the W3C charter, it actually includes, again, a call for an HTTP definition, but it, again, defines it as non-exclusive, meaning that other protocols could be defined in the future. Yep.
You say that SOAP is on the same level as DCOM and RPC?
The question is SOAP on the same level as DCOM and RPC?
As far as complexity goes,
well, it's a little thinner than both of those, right? It's at the same level, but it doesn't define as much. In fact, you could add more to it. In fact, when I get to BizTalk, you'll see how that's the case. But yeah, if there's a bottom-end boundary between the base protocols like TCP/IP, and then above that you've got DCOM, you could sort of see SOAP being at a similar layer. Actually, I got to start moving along here faster. So, working group has now been officially formed. Woohoo! That's good news. First face-to-face will be, I believe, first week of October, and according to the charter, they expect to have the final specification, or what they call a recommendation, done by September of next year. We're planning on doing a SOAP SDK. We currently have a SOAP toolkit that's out there. It's not nearly to the level that we want things to be. We want to make it so that Visual Studio 6 kicks ass for producing SOAP-based solutions. And so we're producing this SOAP SDK. It's part of the web data team, now run by Dave Reed, who previously had shipped like COM+1.0, transaction server, et cetera. So, I mean, he understands what we're trying to do here. And he understands the enterprise needs of these things. It will ultimately replace the toolkit when it comes out. And the plan date is roughly February of next year. Hoping to have beta before the end of this year. And this will be fully supported by PSS. So this is effectively a product. So this is a fully supported add-on to Visual Studio 6 for building and producing SOAP solutions. Will it act as a SOAP server? It will provide the code to have a SOAP server. So, on top of that, once you've got the core protocol, clearly there are scenarios where you're going to need more. You need security, you need reliability, you need routing, and there's other things as well. But you need to start with that simple thing and add more to it. And so this leads us to BizTalk. I'm not going to spend a huge amount of time on this. Just to run through the distinctions again, just to make sure it's clear in everyone's mind. When you talk about BizTalk, there are three main components. There is the BizTalk framework, which is the XML-based definition of how to route messages. So it's like SOAP plus some, which I'll cover in a moment. And it is the base protocol that BizTalk server uses for interoperability. I want to make it clear it is not the only messaging structure that BizTalk server supports. BizTalk server supports many different structures. But in a default case, for interoperability purposes, BizTalk framework is it. BizTalk.org is a site where people can post their schemas so that other people can find them, learn more about what's being built in their space, provide a place to discuss the development of schemas and working on XML. And then finally, where we actually make money on all this, the BizTalk platform, which is, of course, Windows 2000 and, of course, BizTalk Server 2000. So that is our implementation of the schemas and the framework in the first two. So BizTalk Framework 2.0 is significantly different from 1.0 in that it restructured itself so that it used SOAP as the underlying envelope for moving data around. When you looked at, close to a year ago now, when you looked at SOAP 1.0 and BizTalk Framework 1.0, you saw that they both had this pretty much the same envelope structure with a header and a body and so on. And so what we did with SOAP 1.1 and BizTalk Framework 2.0 is created a convergence so that SOAP 1.1 provided the sufficient degree of messaging pieces that BizTalk Framework could then add to that to add on the pieces that it needs. So, for example, if you're sending insurance documents back and forth, the insurance claims may be marked up as XML, but what about the digital images of the car crash that need to go with it? There needed to be a way of attaching those to those messages. And so the framework, in addition to using the basic envelope of SOAP, has added to it the ability to attach non-XML documents. It also provides for things like reliable messaging for exactly once delivery, which again is fairly important. You don't want to be sending a purchase request multiple times just because it failed and end up with 10 copies of whatever it is you bought because you were up at 3 in the morning watching some infomercial. So one of those stomach things. You're not going to use one. You're certainly not going to use 10. Yes? The question is, will those extensions be in a SOAP v. X? And there's a two-part answer to that. The first half is, I don't know. But the second part is, our intention is for this stuff to be open. So we have, same arguments I was using earlier, we have no intention of holding on and locking up the use of the reliable messaging and so on, and the packaging. Again, like the lower level protocol, its value comes from the broader adoption. The value comes from more people doing it. And so we want to get it out in some standards format. The difficulty comes in where the boundaries lie for different standards groups. The W3C has a particular mandate for what they're trying to do. And unfortunately, this whole space is a continuum of pieces. And there's a problem of where different orgs draw their lines. And so, on the one hand, we actually redefined the charter for the XML protocol work in such a way that we could very easily put reliable messaging in, put the packaging in as additional components to the XML protocol work. So we laid out a framework within the activity so that this could happen. The question is, will it play out that way? And we don't know. The good answer, though, is we will make it open. We will work it through a standards process. So whether it becomes SOAP v. something or whether it's part of some other initiative is not clear, but we will try and get it established. So we got all these messages moving around. I need to start describing things because it's getting pretty complex here. So when you think about a web service, the simple scenario is one of, if you think of a web service as being kind of like an interface that you used to have IDLs that were capable of saying, here are my ins, here are my outs. Well, the simple description of SCL, which SCL stands for Service Contract Language, and I'll get back to the name in just a second, is a way of describing your web service. You can think of it in terms of saying, here are my ins and my outs, in terms of the XML documents you can send me and the XML documents you will receive in response. So part of what SCL does is it points to all the schemas of all the documents or all the messages that it will understand. So we're now getting a degree of indirection. So the XML schemas describe the messages. The service description, or the SCL, is used to pull those descriptions together to define how a particular web service might work. Now, the name, SCL, is going to change. You may have first heard of something called SDL, which was Service Description Language. We then changed it to Service Contract Language, and I can't give you specifics, but probably in about a week's time, and I'm just giving you a heads up, so when this new name comes out, you don't say, wait a minute, that sounds a whole lot like this, what are they doing, something new. In about a week's time, a new name will come along. And quite frankly, the new name is not decided yet, and a big part of that is that this is not just us. We are actually working with some people, partners, outside Microsoft, on coming up with a single way of doing this. So instead of having different companies define their own versions of SCL, again, for all the same reasons as we've talked about before with SOAP and the routing and reliable messaging stuff, the value increases the more people do it in the same way. So we're working with other partners to come up with a single definition, and that single definition will have a name. And of course, that name will be different from all the other previous names. But SCL is certainly the one we've been using most recently, but there will be another one, and I can tell you it'll at least end with the letters DL. So it'll be something DL. Yes?
How many can do with UDDI?
No, get into UDDI. UDDI is separate. Once you've got all these services, there's then the issue of coordinating a particular transaction. How do I do a purchase transaction? Well, in fact, a purchase in many instances is not as simple as I send you a purchase order, you ship me something, you give me an invoice. Well, in fact, even right there, right, there's three things. I send a purchase order, I get a confirmation, then I get an invoice. But clearly, they can get far more complex than that. You can have parallel paths. You can have time dependencies. You can have dependencies on outside actions. And so, in addition to defining the node-level service, a web service, there's a need to define the coordination or the orchestration between those services in the execution of a particular transaction. And this is XLang. Who went to the BizTalk orchestration presentation? Okay, good. A good number of you. Again, don't have time to drill in a lot of detail, but I'm going to talk about XLang briefly here. The whole idea is that it is an XML vocabulary for defining processes. So it would then be you would use XLang to describe, again, like the purchase transaction and what are all the things that it points to. And at this point, BizTalk Server is the engine that you're going to use to process XLang documents. One of the cool things about it is that it actually allows you to produce executable processes. And because of the way it abstracts between the actual implementation of a process and the definition of the process as a whole, you can have business managers define the process we're actually using Visio, pardon me, as the template designer, but then have it ultimately bind to a COM object or invoke a web service, doesn't matter. But there's that separation so that the person who understands the business flow doesn't have to be a programmer to define the business relationships. The question here is, what standards body is that getting published to? I'm going to come back to that question in a moment. You know some colors on here, right? Ties in. I wasn't just sloppy. So, I'm building from left to right here because there's this idea that you as a minimum need all this stuff at the wire level, right? That's how you get started. You don't send it over the wire, you can't do anything. But then as soon as you add any of the pieces on the left, right, middle column, description, the part on the left gets a little easier. So as soon as I have a way of formalizing what my documents look like or messages look like with schema, things get a little simpler. As soon as I can formally define my web service with SCL, it gets better. When I can formally define my business processes, it gets a little better. Things get a little more automatic. Software like VisualStudio.net can do a lot more for you. You start moving up the food chain, getting to focus more on the logic part, less on the code plumbing part. But we're still missing a piece because how do you find somebody's web service? And then how do you find out, how do you get that SCL file? And that's what Disco is all about. Disco defines the protocol for how you discover a partner's SCL files, which would then, of course, point off to the messages. So there's a chaining effect here. I want to do business with somebody. I can use Disco to go to a known location. That location will give me information, which points maybe to the SCL files, which then, again, point to the schemas, so that I can then begin producing the messages to do business. But in many cases, I don't even know who the partner is yet. I may just say, I need to talk to somebody who can sell me this or who has that service. And that's where UDDI fits in, UDDI. I'll talk a little bit more about that in a second. But the idea is that UDDI is more generally, and I'm out of time. Thank you all for coming. Universal description, discovery, and integration. This is one of these remarkable times where the name actually tells you something meaningful. Description, discovery, and integration. That's what it's about. That's it. Those are the three main things, or main goals of UDDI. It's a way of describing your business. It's a way of describing the services of your business. It's a way of describing the execution of those services. How are you working those services? Oh, thank you so much. You get to give me a 5. That's not how it works, is it? Well, thank you. So, hey. Oh, and thank you as well. Would you like a drink? Two cool aspects of UDDI. First, what it does, and second is the partnership aspect of it. I think you're probably hearing a pretty consistent message here. This stuff has value when everyone does it the same. And so with all of these things, we've been working with a lot of outside partners on producing these things. And so our goals in all instances are to get the widest adoption of these as possible. And the goal is to find the right vehicle for that. Oops, sorry, that's me again. So, three main things it's trying to accomplish. Increase the scope of B2B. One of the barriers to broader business-to-business connection is the ability to find those connections. Who exists? Who can I do business with electronically? It will help solve that problem. Searching capabilities will be improved because we're providing ways of describing businesses and services that we haven't had, and you can begin mapping that to other information so that a search for products and a search for services will not now bring back gazillions of web pages just because there's some they're doing full text searches that happen to randomly have those words. There's a greater degree of intelligence that can be provided. And then from there, because we have the same metadata describing businesses and services, the ability to aggregate content and aggregate information and services is simpler because we have these very well-defined interfaces and services and messages that we can use. So the idea is that in the V1 time frame, actually, you know what? I'm going to skip right to this next slide. What we have is first you have companies, software companies, and standards organizations, and people who develop programming models or interfaces. They can come to UDDI, uddi.org, or uddi.microsoft.com, pardon me, and they can register those things. So BASDA is an organization that has defined all of the documents necessary for accounting software. The XBRL is the definition for business reporting that's being used for financial reports. HL7 is the definition for insurance. Healthcare, pardon me, healthcare. Sorry, Accord is insurance. HL7 is healthcare, pardon me. So these are all different definitions of information. And it can include things like BizTalk and SOAP as well. So first these things get registered. Then businesses come along and say, here is who I am. And there's a variety of ways in which UDDI allows them to define their business. What's my name? What's my address? Geographic location? What services do I offer? What business am I in? And so on. And then when I say what services I offer, I can then point to those. Actually, in step 1, where you see the woman's face there, when they register these things, those are called T models or technical models. So in step 2, when a business starts to register itself and its services, it will then have its services reference those T models. So it says, I am offering, I am a flower wholesaler, I'm selling flowers wholesale via these services, and I am using this ML blah blah as the way to define how I sell my flowers wholesale. So there's a service registration, the business registration. And when this happens, when these things get put in there, each of them gets a unique identifier. So that the BASTA definitions will only have one identifier. and the XBRL will only have one identifier. Again, it's kind of like a GUID, so that you now have a unique way of referencing, a way of defining information or defining a service or even defining an organization. So we have now these unique identifiers, which now allows marketplaces, search engines, other businesses, even individuals to come to this registry and say, I'm looking for, or I am a flower shop in a particular location, and I want to buy these sorts of flowers, and I know how to speak, so to speak, this type of e-language, let's say, right? I know these T models. And they can use that as a way of finding partners that you can do business with. And then ultimately, when you start building out these systems, and you start getting tools like, VisualStudio.net, then they have the ability to go, even actually Visual Studio 6 today, you have the ability to programmatically go to UDDI, give it the information, have it return you the results, which will then redirect you to the business you want to do business with, using Disco, find the services, and so on. So we've got this very sophisticated way now of both finding and automatically connecting with other businesses. The question is about the T models. Aren't we going to get all these variant T models, and how will people know what to use, and isn't this a chicken-egg problem? The quick answer is actually not. If you remember my discussion about schema earlier and having multiple invoice definitions, BASTA has a definition for an invoice. So does CXML, which is another thing from Commerce One. That's not a problem, because the people who are implementing BASDA are the accounting software, like Quicken and ACPAC and those people. And so they're worrying about how do I get my accounting software to talk to another accounting software product to exchange invoice information. Whereas CXML is looking at the space of how does my company send the invoice to invoice you. And while, again, yes, it would be nice if those things lined up, the fact that in those two scenarios they're different, not a big deal. Now, however, if the accounting software was fractured and there were 10 submissions to deal with accounting software documents, that would be a problem. The reality is that's not happening so much. There's a remarkably good amount or degree of cooperative work going on, at least in the big places, in the places that really matter. In the smaller areas, there's a lot of fragmentation going on. Using things like XSL, the ability to transform between them is actually not that difficult, and you'll get some convergence over time and things will simplify. One of the advantages of a system like this is that it helps prevent it. So I prevent those problems. So I talked about biztalk.org earlier. Biztalk.org continues to exist because it is in fact the repository. It's where BASDA schemas will live. BASDA has already submitted them as the public place where you can go and get the actual schema. But you will also find up on UDDI.org, which is supposed to be up and running within about 30 days, I believe, as a beta, you would find a T model defining the BASDA. Now, it doesn't hold the schemas itself. That T model will simply point to wherever they actually exist. So by having this combination of a place where they live and a place where you can find them, what that means is that if somebody else comes along and says, hey, I'm in this industry and I've had my head in a hole, so I don't know what anybody's doing, then I can go up to the site and find out who else is doing work in this space. So one of the value propositions of all of this is to get the information out in as centralized a way as possible to help minimize some of those problems. I mean, there will be problems in some spaces because you're going to get people fighting and saying, no, my idea is better, no, my idea is better. But the net is that if people, as a minimum, express their information as XML, that's a good thing. Right? So if everybody went off and invented their own invoice, but at least it was still an XML invoice, that's still a good thing. Because moving from an XML invoice to another XML invoice is simpler in most cases than anything else we've ever had to do before. So getting things just into XML, or at least being able to express things as XML, as a default starting point in almost all cases is a good thing. So the lots of variant schemas that may exist early on, again, might slow down in certain pockets, but overall, just getting in the game is the thing that really matters. Those are all the partners who have signed up to say, yep, we think this UDDI is a pretty good thing. Ariba, IBM, and Microsoft were the three that started it. We figured this out, figured out how it worked, started prototyping, and then we said, hey, folks, we think we've got a pretty good solution here. Do you want to join us? And these are all the companies who have said, yeah, we think this is a good idea. In fact, actually, this is sort of redundant. This is kind of walking through a particular scenario, the flower shop one. So, they go to one place, say Sydney.net, which might be like bCentral. So that, they're a small shop. They go to their service provider. Their service provider, in turn, can go and try and discover who the other wholesalers are in their space that can sell to them and provide the information back so that they can do business. Oh, the part I forgot to mention is this stuff works very much in a DNS-like way. That DNS servers run all over the world, so that, but they all give back the same information. So, they're distributed so that you get performance benefits, but the information gets spread across all of them, so that ultimately, if I do a search for any one thing, if it exists within UDDI, it will be found. Yep. If I'm not mistaken, it's held three-way between our implementation, IBM's implementation, and Ariba's implementation, at least for now. A number of those other companies that you saw there will probably also put up their own servers. And then over time, as this stuff moves into a formal standards process, that will help determine how it will be carried forward. As with all things, we fully intend to standardize this stuff. So it's a really key piece in pulling all this stuff together. Again, we're working with an open process, working with partners, publishing this stuff to anybody to use and implement. In fact, IBM, when they release their implementation, their reference implementation, they're actually going to be publishing the source code on Apache, apache.org. And as a result of all this, there's significant momentum already behind UDDI, even though we announced it, what, 2 weeks ago. So, final slide here. The different colors gets back to the space about standardization. So the brown color there, those things are basically done. The sort of rusty color there, those are work in process. As I already said, the schema work is almost done. SOAP 1.1, of course, is done, but the XML protocol, the W3C aspect of it, is just beginning. Pardon me. So it is not an official standard yet, which is sort of the distinction. And then all the green pieces represent future. And future standards is really what I mean here, because we want them to be open standards. We want them to go through a standards process. And one of the reasons is not just to promote, again, the broader adoption, but standards bodies provide a certain degree of validation that these days you can't get from a single vendor. They provide a structure and an environment to evolve the standard and as well maintain the standard. So the question that just came up about, where does this data live? You could apply that to some of these other things as well. Where does the standard live? How does it move forward? What is the mechanism for getting to the next version or deciding that it's reached the end of its life or what have you? In all of these cases where it's green, part of the plan of record in all instances is work it through a standards body to get those benefits. Unfortunately, as I said earlier, which standards body is not always clear. It is not obvious where we need to put some of this stuff. We're looking at it. That's part of what I do, actually. So we're figuring out where is the right place. So we don't have answers to a lot of that now, but you'll see over time, some within the next year, some of it longer. If I was to say what would happen quickly versus not so quickly, the security, reliable messaging, routing probably happened the fastest. SCL and Disco probably close on its heels, as well as UDDI. And the longer term one, I think, is XLang. Because it's getting a little far higher up in the stack, not according to my drawing, but it's getting higher into the application domain. It's not so much down in the infrastructure domain like many of the other pieces. Pardon me? Disco is the official name of the discovery protocol that is currently in VisualStudio.net. Whether that will be the official shipping name is not clear, but Disco is there is a protocol called Disco that is available now. So I'm really running out on time here. So having said all that, are we supporting it? And if you don't say, holy cow, yes, when I get through this, then I've missed something. So first thing you got to do is get this stuff integrated into the operating system. Those core services of XML 1.0 and XSL and all that stuff, they have to be as native to the operating environment as file read, file write commands are. Those things are going to be as ubiquitous. I mean, people will be using XML commands as often as they're using file commands. I mean, it is just becoming a core part of how people are writing their code. And so it needs to be not only available, but well integrated. And so we've been shipping a parser, XML parser, or processor, which is the thing that actually has most of these bits. Shipping as a part of Windows 2000. Ships as a part of Windows 98 and ME. It even ships as a part of Pocket PCs. So anyone who's got a Pocket PC in the room, you've got an XML parser on there, and you could write an XML-enabled app on your Pocket PC today. Or you could write an app that would exchange XML and do something funky with it on the Pocket PC today. Now for those older systems, NT4 boxes in particular, that people are still running where they still need to get in XML services, we've also made the parser available as a standalone component that our ISVs are allowed to redistribute for free so that they can get standards compliant XML support on older machines when necessary. Won't spend too much time on the parser, just emphasizes that MSXML is the name of the DLL that actually has the W3C XML support in it. MSXML2 is what shipped with IE5 and is part of Windows 2000. It's validating, supports 1.0. It's got the document object model, which is also a W3C standard, but it's actually an API. It doesn't define the data layer itself. It's a programming interface for XML. We supported a working draft of XSL. Because of the timing in March of '99, XSL wasn't done yet, so we implemented a working draft. And in fact, it's a good comparison to XML schema right below it, where I mentioned XDR. Similar situation. We wanted to provide the functionality to our customers, knowing full well that it was going to change, but we saw the value in doing it in the short term anyway. So we implemented according to the working draft at the time, and I'll come back to that one on the next slide. Because it's a COM object, it's accessible from virtually any programming language on Windows. Anything running through scripting host can access the parser. So, there is no barrier to getting access to core XML services when you're running on a Windows machine. And in fact, when you're running inside of IE, you also get some display capabilities so that you can actually render XML using either CSS or XSL. So it's not just manipulating it on the middle tier. You can also be displaying it and manipulating it within the browser. MSXML3, we've been shipping a series of tech previews starting in January. It is now officially in beta. It'll be shipping in October. Key focal points for the tech previews that we've been working on and the final release, upping the ante on our standard support, trying to get as high as we possibly can on conformance for XML 1.0, and at the same time getting caught up on the XSL stuff. So as I said, we shipped according to a working draft, which means not done. After we shipped IE5, the final recommendation XSLT came out, so we needed to catch up. So now in MSXML3, we have support for the final recommendations of XSL and XPath. And we also added a new programming interface called SAX2. Don't have a huge amount of time at the end. If anyone wants to ask more about it, I can talk about it. But very simply, the W3C produced a programming interface called the DOM, the Document Object Model, very tree-oriented. All the interfaces are all about walking trees. The problem is when you're dealing with an in-memory tree model. So when you're dealing with very, very large documents, 50 megabytes, or very, very large numbers of messages, thousands or tens of thousands, loading all these things into memory in order to process them is very, very inefficient. And so what's needed instead is a stream-based or event-based interface so that you can just start at one end of the file and rip right through it until you find what you need. And SAX, the original interface, and then SAX2 was designed for just that purpose. Interesting side note about SAX is that it was designed completely on the XML dev discussion list, which is a standard discussion list out on the web, and one guy named David Meganson drove it, but otherwise the standards body that produced it was this discussion list. It's quite an interesting. It was quite an interesting evolution to see how it came along. But it has become a de facto way of doing things as an alternative to the DOM. They're not at odds with each other. They just serve different purposes. There were some issues relating to server-side HTTP access. Anyone who's tried to do SOAP stuff has probably encountered that already. MS-XML3 will help solve that by providing a thread-safe listener. And then in addition to core standard support, we also needed to optimize the parser so that it could crank through documents on the server faster. So it provided the ability to cache style sheets and cache schemas so it doesn't have to keep loading them up into memory. We've been using a web release mechanism to get the stuff out because it's the only way we can keep up with the changing standards. If we try to tie ourselves to a product cycle like SQL or Windows 2000, those things are just moving at a rate that doesn't map to internet speed. So we needed to play in a different game. And so the parser has been going out on a web release cycle. Since January, we've shipped 4 versions of the parser. Again, it'll be going gold in October. After the July release, we had 10,000 downloads of the parser in the first week. The interest in this is huge. It's supported. We have a public news group, and we actually have guys from part of PSS supporting that. So and we have the PMs on there as well. So there's people actually supporting this technically unreleased version of the parser. And it also runs side by side. So it can be installed in parallel with our shipping versions without breaking running apps. Release cycles. Version 2.5 was Windows 2000. SQL Server shipped 2.6. But the one that really counts is version 3.0. Again, shipping October. But we're not letting up on the cycle. We plan to have the 4 version, MS-XML version 4, tech preview out probably about a month after we get version 3 out the door, because the big thing that everyone's going to need next is XML schemas. That is the main standard that people are going to need next, and we need to get it to them as quickly as possible. So we're going to continue to use the web release program on MS-XML4 so we can get it out early, get people beating on it, and get it gold quickly. On the managed side, the story is in fact tons better even. So they took all the stuff we had already learned on the native side with MS-XML. It's fully standards compliant, but in addition to being better integrated with ADO, because of the way they've been reworking ADO+, perf is just awesome. So our parser is already pretty damn fast compared to most other parsers out there, but you can see here that running the same things, both using ASP+ as well as the managed parser, kicks ass. So if anyone's worried about performance, we understand and we're working on it. Perf is one of the top criteria for this stuff. We do not want XML parsing or processing to be a bottleneck anywhere. Developer support. Because it's a COM object, it worked really well with Visual Studio 6 today. You've got multiple interfaces depending on what you're trying to do, DOM, Saxon, ADO. But of course, VisualStudio.net is just so deeply integrated with XML that a lot of the stuff becomes even easier than it is now. We've had lots and lots of sessions. If you've been to any of these, I'm sure you heard them say XML more than just a couple of times. So you have a pretty solid sense of just how deeply ingrained XML support is in these products. And the rest of our products are adopting it at a significant rate as well. In many cases, the XML is not actually surfaced. The customers, the users, don't ever see it, which of course the way it should be. Even developers don't often see that information is being used or stored as XML, but it is there to a greater and greater degree. And then, of course, our own services, our own websites and properties and such are all moving at a faster and faster rate towards using XML as the primary data format. And Microsoft.com, our own website, is one of our showcase accounts. It's one of the busiest sites on the web. So when people say to us, yeah, but can you run a big site? I don't know. Does that one qualify? Usually does. Lycos is switching over to, they're already migrating portions of their site over to XML as well. They're another very large site. So people really are doing this stuff. Some of our top customers here using our core XML engine in varying ways for running their core systems. So I'm just about out of time. But what I want to run through, though, is this last slide because it's really the key one. What it shows is the relationship between the core standards and our implementations, which is the green shell. And the most important thing that I wanted to show here is the separation between the orange and or the varying sort of orange-yellow layers underneath, which are all based on open standards, and the implementation layer, which is where we have the opportunity to innovate and produce incredible products that allow people to build great sites. And I'm actually just going to zip ahead to slide. These slides will be available, so you will be able to see the other points. In fact, all they do is just talk about where the things that we saw in the previous slides fit in. But what I want to get to is this one. Because what this tries to show is how, by using XML for the data, for the envelope, and the protocol for moving data back and forth, you're creating the separation from your implementation. So the fact that I use BizTalk Server to produce and consume messages is independent from how you choose to do that. As long as the contract, which is also defined in XML, is maintained for what we send back and forth over the wire, then we have interoperability. So interoperability does not depend on you and I using the same programming language. It only depends on you and I agreeing on the data that we're going to send back and forth over the wire. Competition in the space, IBM, they've been working very closely with us on the standards, and we're going to compete with them on the implementations. Sun, they've been doing a remarkable amount of work in the standards area, in defining the standards. They have a remarkably poor record for implementation. Oracle has actually done a very good job of implementing XML, but of course it's only for the database, because that's all they've got. So it's a very small and contained story because they're only looking at a very small piece. But quite frankly, they have done a credible job in the parts that they've done. Yeah?
Well, what about Oasis?
Oh yeah, Oasis is another standards body designed for, that's there to try and help build different XML-related standards, more at the application level. And they're also dealing with XML conformance. The conformance space is something that we will, in fact, be participating in the next little while. As everyone fills out, please fill out the evaluation forms. Thank you.